Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In the previous tutorial, we created multiple images from our nighttime lights data sets, and we visually interpret them or evaluated them in terms of possible locations where night lights increase, decrease, specifically because of its relevance to economic activity, etc. So and we basically said that it's quite difficult to visually identify areas that experienced increases or decreases in its night light intensity footprint. So what we want to do in this particular tutorial is to create a script where we simply subtract these images from one another, and so by doing identify locations um, that have what we call experience a temporal difference in their nighttime light intensity. So that's going to be the purpose of this particular video or tutorial. So again, we can go to our Earth engine and we simply click on the code editor. From the code editor, you basically go to your scripts and you search for your script. You double click on the script and it will open the script. So this was just continuing from where we left off. Remember, we've got our region of interest as displayed below. We've got a clipping function, and then we've created two images for both data sets. So we create a beginning image, in this case a 1992 image for DMSP, and we've created the ending image, in this case 2013. So that gives you, what's it, 21 years of time between the first image and the second image. Call it the first and the last image. Remember, you can change those dates. You can add multiple images, etc., etc. And then we've created two images for the VS data set. Call it again a beginning image, 2013, and an ending image, 2023. So that's 10 years. So in general, from 1992 to 2023, you're looking at 31 years of images. Remember, again, with a caveat, you can't simply compare the two data sets. However, you can say it increased during that for that data set, the DMPs, and it increased. And one can assume that will be a continuous increase in night lights. But just be careful in terms of simplifying the relationship between the DMSP data sets and the VS data sets. The sensors in those two satellites were very, very different. Predominantly, I said, because of the blooming effect and the sealing effect. Nonetheless, we've got two sets of images, and we want to create what we call a temporal difference image. So we want to subtract the 2013 and the 1992 image to get a difference image, a temporal difference image. Call it a temporal difference DMSP image, which will be basically 2019, this image, subtracted by that image. And we want to create a temporal difference VS image, which is basically the 23 image, subtracted by the 2013 image. Remember, in both cases, we're still working with the median images. We can, again, change that to mean images, or we can change it to the sum images. But I prefer to work with the median images. We've got our visualization parameters. What I've basically done, just a change, is to make the DMSP visualization parameters 3 and 60. And the reason why I exclude zeros, ones, and twos is because I want to minimize my blooming effect. And then for the VAR, for the VS, I've made it 0 because there's no blooming effect in VS, or very, very little blooming. I can start at 0. But let's say I'm going to start at 1 because I don't want to include areas where there's nothing. And then because there's no upper ceiling, remember, it's actually 63. So let's make the maximum 63. And in this case, there is no maximum, but We still have to add a value, and I'm just giving it a high enough value of 200. I doubt that there's any areas or locations within my region of interest that would have a nighttime light intensity of 200 or more. The color schemes are exactly the same. I add my four images to my layers, and I export it. So that's a standard script with one or two slight modifications. But I said the purpose now is to generate images where I can identify areas or locations which experienced a temporal difference increase in nighttime lights or a temporal difference decrease in nighttime lights. Okay, so how do I do that? Using the following script. And I've already populated the script and there it sits. So I'm going to create a variable and I'm calling that variable subtract by DMSP images. And the code is I take my DS2013 image dot subtract with my 1992 image. So very straightforward. I take my image, my 2013 image, my latter image, dot, and I subtract it in brackets with my initial image or my first image. And I give that variable a name, or I give that image a name. In my case, subtract DMSP. Again, the names of these images or variables are discretionary. It's totally up to you. But anyway, so that's the little script or the code of subtracting images. And obviously, I'm going to give this image another visualization. I'm not going to use my original visualization because my original visualization, obviously the numbers would be much bigger either side than if I subtract them. So in my case, I'm going to have obviously minus values. Remember, in the absolute, there's no minus values. Here I subtract, so I could get a minus value. So I've got a minus 60 and a positive 60. And for now, I'm leaving the palette, the color palette exactly the same. I'm not changing that, but I'm changing the min and the max. And I'm giving that um, visualization parameters a specific name. Remember, I can't have more than one name of the same thing. You have to have different names or unique names. And I do exactly the same for my virs, where I've got the 23 image and I subtract the 2013 image. Again, those are the images as specified in the layers. Remember, there's my 2023 image and my 13 image. So I basically say I'm taking this image and I'm subtracting that image. And that is the code dot subtract. And remember the brackets of your initial image. And I'm giving that also a visualization parameter of minus 100 and 100. Because remember the maximum value is 200. So I'm giving it different visualization parameters then um, the non-difference or the non-subtracted images, which you can see there. But the color scheme are the same, and then I add those two images to my layer. Same code as previously. I just change the name of it or the reference, which is that reference, the colors or the visualization parameter, which is that one, and I'm giving it a name. Okay. Remember to save, always save, and then importantly, you run. Okay. I haven't included the export. Let's rather do that now before we forget. I also want to export these two different images. So I'm going to export the temporal difference DMSP image. I'm going to give it its name, copy and paste its name. And I'm going to export the virs temporal difference image. Let's copy and paste its name in there. And like such. In all cases, the region of interest is my ROI. My folder is the same. My scale is the same. Let's save again. And now I feel comfortable to run it. So let's run it. I'm gonna minimize this particular window so that I have my region of interest displayed as big as possible. And you'll see there should be 6. How many? 6 export um, tasks. Um, the 2 for DMSNP and its temporal difference, 3. The 2 for the VIRS and its temporal difference. So that gives you the 6. Let's count. 1, 2, 3, 4, 5, 6. So it is the 4, let's call it absolute value images, and the 2, let's call it temporal difference images. Okay, so we've played around in our previous tutorial with the, let's call it absolute image of the 2 data sets. So I'm not going to focus too much on that. Let's go to the DMSP temporal difference image. And there it sits. Now remember, I've used the palette. Let's, if you want to click on that nut, let's go there. I've added the palette black, purple, and then the light, call it orange, yellow, red to dark red. And it's from -60 to 60. But you can see from this, you can clearly see the areas that recorded significant increases in nighttime light intensity, which is the dark red. So that is evident, but I don't, in this case, see any areas that have recorded decreases in night light. It may be that there's none, but um, let's explore it a bit more. I can, as I said, definitely see areas that have experienced. Could be that my palette is just not capturing the decrease areas. So let's quickly stretch it for and see what happens there. If I stretch it, this looks a little bit different. Now there's a couple of areas, this black areas, which indicates decreases. Remember, my parameters is now -3 to 4. So the black would capture those areas. So there we go. So a couple of areas, but it's evident that it's by far the minority of locations. Let's stretch it in this range, 4 to 6. Let's apply that and see what happens. You can see still a couple of areas where decrease. Let's go to states 90% of the actual values itself. But you can play around with the numbers. There's from -1 to 44. I think the ideal one in my mind is the -6 to +9, which indicates that most areas recorded a level of increase in nightlight activity over that time, although there's a couple of areas that actually did record. But in most cases, most locations recorded an increase or very little. I think the purple, I think let's make that, in this case, let's make that let's make those two a white and see what happens now. Yeah, so that gives you, I think, a much better representation of the areas if we just make the in between, meaning that areas which is close to 0, change white. Okay, so let's see with the VS. VS, initially you can't see any difference. Because remember, the VS are the values are much closer or much lower. So therefore, the differences will be much more closer to 0 than, let's say, in the DMSP, where you have much a bigger range of values. So I think here we need to play around with the visualization parameters a little bit as well. So let's stretch it a bit so that it's minus and to 0.7, the range. Interestingly, there's much more areas that recorded a decrease in nighttime light intensity according to VIRS through this period 2013 to 2023 than DMSP, which recorded from 1992 to 2013. Now, if you just look at the periods, and obviously this makes sense as well, because in general in South Africa, from 1992 till 2013, there was significant economic expansion and growth and electrification and expansion of industries, etc., etc. Whereas post 2013, you had a number of crises, most predominantly the COVID crisis of 2019, 2020, 2021. In fact, one can actually go and model that as well, which we may do in a later stage. But yeah, so in this case, you can clearly see that there's a number of locations where they recorded decreases in their nighttime light intensity um, compared to and it doesn't matter which method of visualization or parameter of visualization you're using, the areas are basically not that different. So let's quickly go back to our initial stretch parameter. And let's um, make that the, the white as well. Let's see, I want to make it as a white color. Um, I don't want to make it, okay, there's white. Let's make it that white color there and apply. And yeah, so it's still a little bit of pinkish, but let's make it the two extreme colors and apply. There we go. And let's make the black. We're going to make, let's cancel the black. Okay, so let's change the color scheme a little bit. Sorry, let's quickly change it a little bit and make where there's growth, let's make that a nice green, indicating positive stuff. Then, sorry, um, that must be red, dark red for the negative, and then there is white, 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 and then we're going to make the green. Um, okay, so let's try that one and see how that comes out. Okay, so the green in this case is areas that recorded positive increases in nightlight intensity, whereas the red is areas that recorded negative. So now you can clearly make a distinction between the areas that have recorded um, decreases, and I want to import this um, color scheme. So I go there and I basically copy that specific palette, and then I'm gonna um, find the visualization parameters in my script itself, and I'm gonna change it. Remember, there's two of them. So let's rerun the code now. So I'm gonna go and delete that. I'm gonna close here and let's rerun the code. And it should give you that color scheme now for both the DMSP temporal difference image and the VS temporal difference image. Okay, so let's zoom in a little bit. Interestingly, yeah, it doesn't. Yeah, so in the DMSNP, it displays the green. It only indicates areas of increase in nightlight intensity, which predominantly is around this particular area. In the VS, also don't show that simply because we haven't applied the stretch function, and that's the reason why it's not showing as clearly. And let's go there. So maybe we must go back to the original. Nonetheless, we can play around with the color schemes, and yeah, there it goes. So that's the DMSP. You can see the areas of increase and decrease in nighttime lights. If we go there, so let's go stage 2, and we click that. There we go as well. There we go. Nicely done. So you can see that's the temporal difference in the DMS in P. nighttime light intensity per location, and that is according to VS. Okay, so remember to save. So this was a quick tutorial, and the purpose of this tutorial is just to create two temporal difference image so that we can visually identify areas or locations that recorded increases in their nighttime light intensity and areas or locations that recorded decreases in night light time intensity, and also just to play around with the visualization parameters so that the images display those characteristics of dynamics much more efficient and effective than just having a very static visualization parameters. Remember to save, and as I said, we can now run all these images. So um, for now, I'm gonna um, close this tutorial um, whilst I am running it. So in our next tutorial, we're gonna play around with the saved images as a starting block and continue our work on remote sensing with nighttime light intensity. I trust you enjoyed this tutorial and find it useful in your journey of exploration of remote sensing, and I'll speak to you soon.